Hello, sophomores. Welcome to the Chemical Analysis and Nanochemistry Research Lab. This is Dr. Kennedy, the lab director of the Chemistry Research Lab. So my videos today and my PowerPoint will provide an overview of the Chemistry Research Lab and the prerequisites and some of the opportunities that you can expect to have within the lab. I'm going on about 20 years of teaching at TJ and have guided probably nearly 1,000 students through chemistry research projects over the years. Many students have gone through the lab with, of course, interest in chemistry beyond TJ and interest in medicine or pre-law or pharmacy or engineering or finance, really anything related to STEM and sometimes not related to STEM because students are still just curious about the science, the chemistry, the central science behind all other sciences and how it interrelates to other aspects of their interest areas. In the lab, we have many different types of project areas, theme-hood areas, lab bench areas, and equipment for student projects and exploration. Projects can take on many forms related to chemistry, environmental sciences, biology. Among the many types of equipment we have in the lab, one of which is called a Fourier transform infrared spectrometer, or FTIR for short. In this instrument, you can essentially make or create a bond energy map of the bonds within a molecule, and from that, determine functional groups and begin to determine molecular structure. A UV-Vis spectrometer can be used to very sensitively measure how much of a sample is present or how much of a chemical is present in a sample. You may have used a version of that in biology or chemistry called a visible spectrometer. And here we have what's called a fluorescent spectrometer, which measures the fluorescent properties of molecules, which is used quite a bit in projects related to nanochemistry, nanotechnology. Some students have begun doing projects related to studying the interaction of nanoparticles in a neuroscience type manner. So the lab is very well spread out and spacious, lots of room for project setup, equipment setup, student projects, lab work. Over here, we have what's called a gas chromatograph mass spectrometer. It's a two-part instrument, gas chromatograph and mass spectrometer, or GCMS for short. The gas chromatograph, what that does, provides a way to separate out mixtures of compounds in a sample. And then the mass spectrometer on the left-hand side is the detector to determine what compounds are actually present. So what I'm going to show you here on the screen is an example of a student project. And one of the ones from last year was students were looking at the types of chemicals present as a residue on used currency. So the simple way of doing the analysis could be you could just soak a dollar bill in solvent and do an extraction. So when you analyze the extraction, what the gas chromatograph does is it provides a graph or a spectrum of all the different compounds in the sample. So each peak you see there in the yellow area represents a different compound that comes off the column as a function of time. So things with a low boiling point are on the left, and things with a high boiling point are on the right, and they take more time to come off the column. In the bottom part of the graph is what's called the mass spectrum. So what we can do is I can look at in the yellow graph and select a peak and say, I want to look at what is this peak. And what we can do when we analyze the peak is do what's called a similarity search with the software. And the similarity search will create for you what's called the mass spectrum, which shows you essentially a map of the different particle sizes or fragments of a molecule. And from that similarity search, you can do a comparison to see what kinds of compounds are present. So in this sample, we see a lot of things like oils, like oleic acid from French fries. We see a lot of different oils from hand lotions in currency and other normal things you would expect like that. But occasionally, the students were able to find some residues from different illicit drugs, like THC from marijuana or cocaine residue on $20 bills. Overall, it's a very powerful instrument for determining exactly what kinds of compounds you have in an unknown sample. Other applications of this for environmental analysis have included air sampling, water analysis, and soil analysis. The
And ultimately,
GC-MS can really be used for many types of applications related to chemical analysis. It's actually one of the more powerful tools in the lab. We have attached to it several different library databases comprised of about 1 million compounds. So anything that you want to analyze or characterize, this instrument can pretty much determine what it is. So other aspects of the lab include different equipments for nanotechnology, nanoparticle synthesis, looking at how to nanofabricate things. We can use what's called an ultrasonicator or ultrasonic probe to help mix the nanoparticles into homogeneous solutions. We also have what's called a Form 3 3D printer. So students have used this to nanofabricate or 3D print small apparatus or devices to go with their projects. Some other applications I'll talk about later include the 3D printing of microfluidic devices for miniature reaction chambers. And on the right there, we have what's called a rotovat for doing distillation of organic solvents from products. And then throughout the lab, there's other types of equipment for different types of chemical analysis applications. Here we have what's called a liquid chromatograph for analyzing unknown mixtures of solutions, commonly organic solutions. And like I said before, there's a variety of equipment and project areas within the lab. So in the next part of the presentation, I'm going to explain a PowerPoint and some of the background and materials and prerequisites for the research lab. Overall, in my past 20 or so years as a high school teacher, it's been an exciting place for nearly 1,000 or more students to do their senior research at TJ. I look forward to having you as a student in the near future. In this portion of the video, I wanted to talk a little bit more about the course requirements and give some basic examples of the types of projects that can be accomplished within the Chemical Analysis Research Lab. So as I stated before, there have been many students I've taught over the years. This is going on my 20th year at TJ and 23rd year as a high school teacher. And many students over the years, of course, have come into the lab because they're curious about chemistry or still curious about STEM-related areas. And students have come into the lab with goals of going to college to study chemistry, and many have come into the lab knowing they're going to study some other aspect of science or engineering, or maybe go off to law school or medical school or finance or some other area where they really were just curious about chemistry and wanted to learn more about the applications of the instrumentation in the lab and how it may help them in the future in a variety of ways. For current students, the primary prerequisite is just TJ Chemistry 1. So AP Chemistry is not required for the Chemical Analysis Research Lab. Depending on your project type, AP Chemistry and or Organic Chemistry may be recommended, but for most projects, Chemistry 1 is sufficient. Some examples of research projects in general are listed here. So things can range, again, like I said before, from environmental analysis of water systems or soils or water, many kinds of projects involving nanotechnology and nanochemistry. Students have, of late, done a lot of projects involving the development of smartphone apps for chemical analysis, or integrated the 3D printing of different types of holders or devices that can be used with a smartphone for doing chemical analysis. Other students have used our Form 3 printer, 3D printer, to fabricate what are called microfluidic reactors. Many students have done things like making organic molecules that could function as things like light emitting diodes, or looked at the degradation of different molecules they've made. And there have also been projects that have carried on different times at different years involving, as an example, the recycling of metals using electricity. And a project a few years ago was trying to integrate a solar panel with the recycling of metals as a way to get metals out of wastewater solutions. So overall, there's many kinds of projects you can do within the chemical analysis lab. To give better examples, here's an example where you could use gold chloride to make gold nanoparticles, which can then be used to make different kinds of chemical sensors. So in this example, students were using green tea to serve as the antioxidant that would help reduce the gold metal ions to gold nanoparticles. Some applications of that could be making nanoscale silver wires. You could look at doing nanoscale single place reaction between metals. Or you can make what are called sputtered copper metal or dilute silver nitrate solutions. So with that, you can essentially make different types of nanowires with different types of metals on them. So again, this is just an example of an application of nanotechnology to make something that could be used for a different device or a different application in the real world. Other examples have been making what are called hollow gold or silver nanoparticles. Again, just changing the properties of nanoparticles to give the chemical makeup a different attribute for different applications. And of course, in this case, the students were making a smartphone colorimeter to be able to use pictures from your smartphone to do chemical analysis of unknown systems. So in this case, the advantages are you could take your smartphone out into the environment or the real world and have a very miniature remote detection system. So here's an example of what I have mentioned before, making a microfluidic reactor. So in this case, a real simple diagram is shown there where you have two reactants enter into the flow chamber, and as they flow through the chamber, they react and mix, and the output, you can then collect your sample and then do different types of analysis. So some of the examples here, we're making magnetic nanoparticles for waste remediation, or making gold nanoparticles for a different application, or making different types of organic dyes. So in each case, sometimes it helps to be able to make very, very small quantities of material, so you're using less reactant and producing less waste as the outcome. So I wanted to make sure I saved time for questions. So after this video, there'll be plenty of time for questions, ideally about the Chemical Analysis Research Lab, maybe questions you have about organic chemistry, and of course, you can ask questions about summer internships, how can you get into mentorship, or other questions you may have. So thank you for coming, and I hope you have a good afternoon.